Welcome to the engineering technology class for December the 1st. I have looked at the things that you submitted as the final project for the electrical engineering unit. And in most cases, it looks really good. You guys did an excellent job there. In a few cases, you had a couple things wrong, but oh well. So hopefully now you have a better feel for what it is that electrical engineers do and how it is that electrical engineering and computer engineering, software engineering, they're really closely related. And so hopefully now you can understand why in many schools, including the University of Utah, they actually teach them together in the same department. Up at the U of U, they have one department that is electrical and computer engineering together because they're so closely related. Now they do have a separate software engineering, which actually they call it computer science. But okay, let's not get hung up in the details. Okay, today we are going to start into a new unit. The new unit is going to be on mechanical engineering, and we will probably finish off the year in this unit. Now you might think, well, that's an awful long time to spend on one unit because, you know, that's the middle of January. Heck, that's 6 weeks away from here. Well, don't forget that 2 of those weeks are the winter break. So it's not really 6 weeks, it's really more like 4 weeks. And also don't forget that there is a state mandated test that I have to give you in January. When we come back from the break, there's a test that the state of Utah wrote that you guys need to take. And so we need to allow time for that as well. Okay, so mechanical engineering. Let's see. Callie, would you mind unmuting yourself and tell us what do mechanical engineers do?
They can build stuff or work with like machines.
Okay, the build stuff is a little vague. Work with machines, okay, that's a little bit more. Anybody else want to elaborate on that, or are you going to call that good? Can anybody else give us a little bit more specific? What is it about mechanical engineers that's unique?
Mechanical engineers design like machines, like she was saying. They could design them or like critique them. So like a builder gives them an idea and they would tell them the flaws or the pros, etc.
Okay, all right. Okay, I like those answers. There is another way to think about it. The word mechanics has a very special meaning. In physics, as you guys know, I also teach physics. There is a branch of physics that's called mechanics, and it deals with things that move. So the study of mechanics in physics is the study of things that move. So a mechanical engineer is an engineer who deals with things that move. All right, so if a machine moves, that would be a mechanical engineer. If you've got a machine that doesn't move, it just sits there and maybe, okay, so doesn't really have any moving parts. Yeah, maybe that's a mechanical engineer that designed it, or maybe it's a civil engineer that designed it. But if it has moving parts, then definitely there's a mechanical engineer involved. Things like cars, airplanes, a clock, anything that has moving parts, that's the field for a mechanical engineer. All right, so what we're going to do is we're going to learn how to design and build things that move. The first couple of weeks here, we're going to be focused on just designing things. And then toward the latter part of it, we will actually build something that has moving parts. And then that'll be your final exam for this unit, will be that you'll need to build a thing with some moving parts. And we'll talk more about that later. But for right now, let's just focus on the design part. Now, one thing that is tremendously helpful when you're designing stuff is to draw a picture of it. There's a lot of reasons why it's important. One is that it helps you to visualize all the different pieces and how they might fit together and all that kind of stuff. Drawing a sketch is a tremendous way to do that. But also, when you actually go to build the thing, you're probably not going to cut out all of the pieces of wood and the metal and drill all the holes. You're probably not going to do that yourself if you're a mechanical engineer. What's most likely going to happen is you're going to design the pieces. You're going to make drawings showing how big each piece needs to be and the holes and where they go and how they fit together. And you're probably going to take your design drawings and hand them off to someone else who will then do the work of actually building them. So you may have heard the term machinist. Maybe some of your parents or relatives are machinists. So a machinist is somebody who receives drawings from a mechanical engineer, and they look at the drawings and says, okay, I need a piece that's this big, this thick, it's got a hole in it right here of this size, you know, and the machinist is the one that actually cuts the metal, drills the holes, and does that type of work. So usually mechanical engineers only do the designing, and usually somebody else does the building. Okay, so in order for them to build things the way that you want them to be built, you have to give them a very well done, easy to understand drawing. So the focus for today and probably also on Thursday is going to be how do engineers draw things? And your homework tonight is going to be drawing things. And so let me share a screen with you. Okay, hang on a sec while I get it here. Okay. All right, what you are seeing right now is a drawing. Now, this is a drawing using a particular style that is very popular with artists. And it's similar to the way that engineers draw things, but it's not exactly the same. There is a difference. I want to take a quick poll here. I want everybody to type in something into the chat box. So the question I want you to answer is, have you ever had or are you currently taking an art class? So type in yes if you are currently taking one or have ever taken one. So I see a lot of yeses and I see a few no's. Okay, it looks like it's pretty close to half and half. Maybe a couple more yeses than no's, but not many. Mostly half and half. And one person says hasn't taken an actual class, but his mother has taught him. Okay, so that counts. All right. So in your art class, you should have heard a term that's called 2-point perspective. Let's see, those of you that took an art class here, Sophia, you said that you took an art class. So I hope you don't mind me putting you on the spot here. Can you unmute yourself and tell me what is a 2-point perspective drawing?
I don't exactly remember the whole thing, but basically my art teacher was like, we put a dot on our paper, like if it was like a center or somewhere off to the side. And from there you would take like a line or like with a ruler and draw certain lines. So it wouldn't be 3D, but it was like it was almost standing up in some parts, but then on other parts it kind of looked like flat. I don't know how to explain it that well,
Okay.
but
No, I think you did a pretty good job. Okay, so this drawing that you guys are seeing right now is a 2-point perspective drawing. So what I'm going to do is I'm going to make it a little smaller so that I can add some things in here. Okay, let's go back to this view. Okay, so I'm going to show you how the person who drew this used the 2-point perspective technique when they drew it. Okay, so the first thing they did, well, actually, let me just, let's see if we can find what's called the vanishing point. Did I ring some bells here? Okay, so if I look at there's a line that, let me make it a little thicker here so you can see. If I look at the roof line, the lower roof line, and I continue that point out for there, and then I look at the ground line and I continue that point out to there, you see there's a point there where those two guys intersect. And if I look at any other lines, let's look at the lines of the windows. You see how they come into that same place right there. And if I look at this roof line here, I see all of those lines are parallel to each other. Let's look. Okay, so here is the little patio in the front there, the little porch roof. Okay, so all of those lines, they all come together at one point. Okay, and so this is called the vanishing point. And in a 2-point perspective drawing, there's a vanishing point on the left side, and there's also a vanishing point on the right side. So if we were to follow this line over here, okay, it goes off that way, and then follow this line right here, it goes off this way, and what we'll find is there's another vanishing point. And any other lines here, like say, look at that window. Okay, if we look at the lines in the window there, those lines also come together at the same, they all come to the same vanishing point. Okay, so we have a vanishing point on the right, and we have a vanishing point on the left. And usually these two vanishing points are on the same horizontal line. So in my case, maybe they're a little bit off just because I was a little sloppy when I drew them. Okay, so this horizontal line here, let me clear my screen here. That horizontal line there, okay, well, that is called the horizon line. Okay, and so the vanishing points are generally on the horizon line. Okay, so these guys go off to here, these guys go off to there. Okay, and you can see that this drawing, I mean, this looks very realistic. That is, in fact, the way that things appear to the human eye. When, you know, if you look at a real house, this is the way the real houses look. Okay, so now in real life, if you were to stand in the very front of the house, I mean, see, if you look right here, the key point of a 2-point perspective, or the key thing to remember about a 2-point perspective drawing, is that we're not standing right in front of the house. We're standing so that one of the corners of the house is closer to us than any other part of the house. So this corner that you see right here, okay, this is the corner that's the closest to us. And so when we draw a 2-point perspective drawing of some object, we are assuming that we are not standing directly in front of the face. So like, you know, if you had a person standing right here directly in front of the house, they would not see the house in the same way that we would see it. If you were standing directly in front of the house and you drew the view of, well, the way that the house looked when you were directly in front of it, it would look more like this. Hang on, let me open up a whiteboard here. Okay, so if you were standing directly in front of the house, here's the door, here's the roof. That's a terrible roof. Let me see if I can fix that. In fact, let me start all over again. Let me try to do this a little more carefully. Okay, here's the door. Okay, and here's the roof. Okay, and then maybe a window here. Okay, so this is what I'm going to call the front view. Okay, and so this corner that you see right here, this was the corner that we were looking at just a minute ago. This was the corner that was closest to the observer. So in the drawing that we saw a minute ago, we were assuming that the observer was standing here. So they were looking at the car, at the house, not from a front view, but from a corner view. Okay, so if you're standing in front of the house, so let me do that in red. Okay, so this is the person standing in front of the house. Okay, so if you're standing in front of the house, notice that this line right here and this line here, this line right here, they are all parallel to each other. If I were to continue this line out and continue this line out and continue this line out, those lines would not come together. There would not be a vanishing point. Okay, but if I look at it from the corner view, so let's go back. Let's go back here to the drawing of the house again from here. Okay, so if I look at it from the corner view, then that's when I see that the lines all converge. So these lines right here that did not converge when I was looking at it from the front view, they do converge if I'm standing here in front of the corner. Okay. Now, so this is a drawing technique that artists use, and the reason that artists use it is because it mimics what you actually see in real life. Okay, but engineers generally don't do drawings like that. Engineers, let me come back here. Okay, engineers don't normally do what's called a perspective drawing. Engineers do what's called an isometric drawing. Okay, so on the left side here, this is the perspective drawing. So if we trace all these lines out, we'll find that they will all eventually come together at some point here. If we trace these guys out, we'll find that they all come together. Okay. That is not the way it works with the engineering drawing. So this is an artistic drawing. Over on the left side here, this is an engineering drawing. Okay. So this is called 2-point perspective. The one on the right here, let me clear some space here. The one on the right here is called 2-point isometric. Okay, and the one on the left is 2-point perspective. Okay, so isometric means that all of the lines are parallel to each other. So what you can see here is that if we've got the cube positioned so that one of the corners of the cube is closest to us. So this is what I called the corner view here. So isometric drawings are similar to perspective drawings in that they start off with one of the corners, and we want to start with the corner that's the closest one to us, okay? And then we pretend that there is a vanishing point. So we have a line right here that goes off exactly the same as it would if it was going to a vanishing point. So if we say this is the horizon and here's our vanishing point, and over here is our vanishing point. So the lines on the bottom go off to the vanishing point exactly the same way that they did with our artistic drawing here. But now here's where it gets different. The line on the top here, instead of going to the vanishing point, like see if you look over on the left side, you see that line and the bottom line, they both go to the same vanishing point. With the engineering drawing, that's not the case. This top drawing and this bottom drawing are parallel. Okay, over here, they are not parallel. Would help if I could spell parallel properly. Okay, that is the big difference between the way that engineers do drawings and the way that artists do drawings. So you can see here that the 2-point isometric drawing looks very, very similar to the 2-point perspective drawing, but not exactly the same because the lines are parallel. Okay, so let's go back now to a couple slides here. Okay, so in the upper right of the screen here, and let me move this thing over. Okay, all right. So let's suppose that I asked you to make a 2-point perspective drawing of some object. Let's just say it's a box. It's not a house, it's just a box. And I want you to make a 2-point perspective drawing of the box. Okay, so the first thing you need to realize is that when I ask for 2-point perspective, what it means is that I'm assuming that the box is oriented so that one of the corners is closer to us than any other part of the box. So all these different boxes that you see here, they all have one thing in common. That one corner there, that's the corner that's the closest to us. So if I ask you to draw a 2-point isometric drawing of a box, so the first thing you need to do is you need to figure out, okay, how am I going to orient the box? So, and the answer to that is you're going to orient it so that one of the corners of the box is closest to you. All right, the next question you need to ask yourself is, do I want to orient myself so that I'm looking down on the box from above, which means a picture like this, or do I want to orient myself so that I'm looking up at the box from below, which means that I would orient it like this? Or the third choice is that maybe you're going to orient yourself so that you're looking at the box in such a way that you cannot see the top of the box and you also cannot see the bottom of the box. So like, for instance, this one right here. Okay, so in that case, you can't see either the top or the bottom of the box. Whereas in this case, you can see the top of the box. And in this case, you can see the bottom of the box. Okay, so that's a decision that you need to make before you start drawing the box. All right, so let's suppose that I tell you that I want to see the box from a view where you're above looking down, so you're going to see the top of the box. So that means you're going to want to draw one of these right here. Okay, so the way you're going to do this is the first thing you want to do is you want to draw a horizon line. Okay, and then you're going to draw the corner of the box that's the closest to you. Okay, now if you've decided that you want the view to be of the box from above, then when you draw that corner of the box, you want to draw that corner of the box so that it is below the horizon line. Now, if I told you the other way, if I said that I want you to look at the box from from a view below looking up, so you see the bottom of the box, then you would draw the corner of the box above the horizon line. Okay, so step one, draw a horizon line. Step two, you're going to draw the corner of the box, but the corner that's closest to you, but you got to decide, are you going to draw it above the horizon line or below the horizon line? And that depends on whether you want to look at it from above or look at it from below. Okay, the next decision that you need to make is you need to decide, are you looking at the box so that you see both sides of the box pretty much equally, or are you positioned? So in other words, let's suppose that here's the box. This is a top-down view. Let's suppose you're in a helicopter above looking down. Okay, so if the observer is right here, you can see how this part of the box goes off at an angle here that is equal to this angle right here. So this person on the box is kind of, so he's kind of exactly in the corner. Okay, so if this is your view, let's call this A, and I'm going to draw this box here A. Okay, so the other way that we could do it is, let me put the observer in a different place. Let's suppose that the observer is over here, so that they are closer to this line. So So the angle here is not 45 degrees. Okay, the angle here is something less. So when they look at the box, they're going to see this side of the box really well. They're not going to see very much of this side. They'll see a little bit, but not much. Okay, so you can see that that corresponds to this view right here. So this would be what I would call the view that a person located at point B would see. And then we could also do it for point C. Let's suppose we have somebody over here located at point C. So that means they can see this side of the box really well, not so much this side of the box. Okay, so if they were to draw the picture, they would see something like this. Okay, so we need to decide, do we want to put the corner of the box, do we want to put it above the horizon line or below the horizon line? But then we also need to decide which view do we want? Do we want the A view? Do we want the B view, or do we want the C view? Okay, so if we want the A view, then what we want is when we draw the corner of the box, we want to put the corner of the box so that it's approximately halfway between the vanishing point. So we got a vanishing point on the left, we got a vanishing point on the right. So when I draw that corner of the box, it's approximately halfway in between. You know, it doesn't have to be exactly halfway, but it has to be close. Okay. If, on the other hand, I want to do the drawing of the box as viewed by a person here, I'm going to call this the B view. So that would be this view. So I can see this side of the box really well, this side not so much. Okay, then when I draw this corner right here, I want to draw the corner so it's really close to the vanishing point on the right. Okay. All right. So now you can see you have a lot of choices on where you're going to put this corner of the box here. Are you going to put it above the horizon? Are you going to put it below the horizon? Are you going to put it to where it's kind of halfway in between the vanishing points? Or are you going to put it closer to this vanishing point? Or are you going to put it closer to that vanishing point? Okay, those are the decisions that you need to make before you draw anything. All right, so let's suppose that we want this view right here. We want to draw the view. So if we go down to our top-down picture again, okay, we want to, I'm going to call this the A view. We want it so that we have pretty much an equal view of this side as we do of this side. Okay, so then you'll notice we've drawn this line, and we've drawn it, and also we've decided that we want to look at it as if we're on the top looking down. Okay, so we've drawn this corner of the box. You'll notice we drew it below the horizon line, and we drew it approximately halfway between the two vanishing points. All right, from here on out, it's really easy. There's not really any more decisions to make. From here on out, all we do is, okay, so we draw that corner first. And then what we do is we draw this line. Now, what some artists do is they draw this line in pencil. And then they draw this line in pencil, and they draw those lines so that they come together. And then after they've drawn the lines, then they come back with an eraser, and they erase everything except for this part right here and that part right there. Okay. And then we do the same thing on this side. Okay, so we have a line here and a line here, and we have this line right here. And by the way, this line here, okay, so we got 3 lines all coming to that vanishing point, 3 lines all coming to this vanishing point. And then once we do that, then we do the other corner here and the other corner here. Now notice that all 3 of the corners, they are all perfectly vertical. But the other lines, they all go off to a vanishing point. Okay, so if I were to ask you to draw a box using 2-point perspective, would you be able to do it? So I want you to type in yes or no into the chat box. Yes means, yeah, you could draw a box using 2-point perspective. No means no. Okay, good. All right, now, what if I asked you to draw that same box using a 2-point isometric? Okay, well, you'd start off asking yourself the exact same questions that the artist who's using the perspective drawing views. Okay, so first you need to ask yourself, do I want to look from the top down so that I see the top of the box? Do I want to do from the bottom so that I see the bottom box? Or do I want to do a view kind of like this one right here where I don't see either the top or the bottom? The engineer needs to ask themselves the exact same question that the artist has to ask. Okay. So what the engineer here, so let's open up a new whiteboard here. Okay, so let's see, Sophia, I want you to answer the questions. So the first question is, do you want to be viewing the box from above looking down or from below looking up? What would you prefer?
Below looking up.
Okay, all right, so below looking up. So that means when I make my horizon line here and I have my two vanishing points, I'm going to put the corner of the box either up here, or maybe I might put it here or maybe here, but definitely I'm going to put it above the horizon line because Sophia said that she wanted to be from the bottom looking up. Okay, all right, so now the question is, which one of these do I want? So the next one here, so Anish, do you want to be looking so that you have an equal view of the left and the right side, or do you want to favor the right side or favor the left side? Which would you prefer?
Equal.
Equal. Okay. So then, Anish, where should I put my, so these lines that I just drew right up here, which one of these lines should I go with? A, B, C, D, or E if I want to see equals left and right?
Probably C.
Yeah, definitely C is what I'd want. Okay, so let me get rid of all those other ones that are not C. In fact, let me get rid of all of them. And I'll just go, okay, so there's my C. All right, okay, so now, now I'm ready to draw the lines. So I'm gonna have a line here that goes off as if it was going to that vanishing point. A line here that goes off as if it was going to that vanishing point. Now, here is where we start in the first thing that's different from the way that engineers do it compared to the way that artists do. So if I was an artist, my next line would be a line that looked like that. Okay, but I'm not an artist, I'm an engineer. So that next line that I'm going to draw is not going to go off to the vanishing point, but instead that next line is going to be parallel to the lower line. And then same thing with the other line over here. It's not going to go off to the vanishing point. It's going to be parallel to it. Okay, then I'm going to put my other corners here. And then I've got this corner here. Now, if I was an artist, I would draw it so that it goes to that vanishing point. But I'm not an artist. I'm an engineer. So instead, what I'm going to do is I'm going to make it be parallel to those other lines. And then this one here is going to be parallel. That's not a very parallel one. Let me fix that one. That was a terrible one. Okay. Yeah, that's a little bit better. Okay. So there is a box that I have drawn using 2-point isometric. Okay. As opposed to the way that an artist would have done it. An artist would have done 2-point perspective. Okay. Everybody clear on that? Okay. Now, there is another view that you need to know about, and it's called 1-point perspective, and there's also a corresponding 1-point isometric. Here is an artist's drawing, and you can see that in this case, when the artist drew the lines here, if you look at these lines, let's see, hang on a second here. Let me okay. So if you look at this line right here, and then any of these horizontal lines here, any line here that's horizontal, you see they're not really going off to a vanishing point. What you see is all of these lines are basically parallel to each other. They do not go to a vanishing point. Or if you like to think about it another way, you can say that they do go to a vanishing point. It's just that that vanishing point is infinitely far away. That's another way of thinking about it. Okay, so what we have here is a drawing technique that's called 1-point perspective. So all of the lines over here right, these lines here, those lines do go to a common vanishing point, but the lines that go to the left, so we start off at this corner, same as we did before, okay? But the lines that go to the left, they are all parallel to each other. The lines that go to the right, those ones go to a vanishing point. So this is a technique that's called one-point perspective. And so this is something where you're pretty much standing in front of the house, maybe standing exactly in front of the house, but not necessarily, not always exactly in front of the house. Okay, and so you can see that we can do it this way. We have a horizon line, so you can see here. Here's the horizon line. Here's our one vanishing point, and we only have one vanishing point. So if I want to look at this view here, so those are the only lines that go to the vanishing point. These guys, they're all just perfectly horizontal. They don't go to the vanishing point. All right, so this is a technique called one-point perspective. Okay, and I'm sure you can see that there would be a similar technique for an engineer. If an engineer wanted to draw something like that, we could just do it this way. Okay, so let's get a, so here's my horizon line, here's my vanishing point. So then what I can do then is I can say, well, here's the box that I want to draw, and this time let's draw it below the horizon line. So because this time, just to be different, I want to draw it so that I'm going to see the top part of the box. Okay, so now an artist would draw it like this, but I'm not an artist, I'm an engineer. So I'm going to erase those. But the first line that I draw is going to be the same that an artist would. So I don't care which line it is. Let's make it be this line right here. So I'm going to draw this line as if it's going to that vanishing point. Now, when I draw the rest of the lines, they are all going to be parallel to that first line. And then the back face, they are all going to be, this line here is going to be perfectly horizontal, just like its neighbors were. This one's going to be perfectly vertical. So here is a picture of a box using what we call one-point isometric. As opposed to if I was an artist, okay, if I was an artist, I would have done it like this, except I need to erase this. Let me do that again. I would have done that, and then going like that, and then that. Okay, so you can see one-point isometric versus one-point perspective. Okay, all right, so this is the way that engineers do it. And so in your homework tonight, I'm going to ask you to draw something, and I want you to draw it. Actually, I'm going to have you do it both ways. I'm going to have you draw it the way that an artist does, and then I'm also going to have you draw it the way that an engineer does. Now, one last thing I need to tell you, one-point isometric sometimes has another name. It's called oblique. So sometimes you'll see people refer to it as an oblique drawing, and other times you'll see people refer to it as a one-point isometric drawing, and they are just two different words that mean the same thing. Okay. So if I were to give you a homework assignment tonight where I ask you to draw something using these 4 different techniques, then would you be able to do it? Type in yes if you think you could, type in no if you think not. Okay, all right, I'm seeing lots of yeses, and I'm seeing a maybe, but it looks like everybody's saying yes. Okay, so let's go on Canvas here real quick, and let me just show you, hang on a second here while I get Canvas up here. Okay, now let me share my screen. All right, so let's go into the engineering page and go to modules. And then we go down here. So you see there's a bunch of assignments down here that I have on here. You don't see them yet because I haven't yet published those. The only ones that you're going to see are the ones where I have the green circle here. Okay, so this assignment right here, engineering drawing versus artist drawing. Okay, so I've got a couple examples here just to help remind you how this works. So you can see here, I've given you an example of a 1-point perspective, an example of a 2-point perspective, an example of 2-point isometric, and an example of 1-point isometric, which is also called oblique here. Okay, so here's what I want you to do for your homework assignment tonight. I want you to draw a picture of a bookcase that has 3 shelves in it, no books, no nothing else on it, just shelves, just a bookcase with 3 shelves. Okay, other than that, it's totally empty. All right, when you do the drawing, I want first using 2-point perspective, and then do it again using 1-point perspective, and then do it again using 2-point isometric, and then finally do it again using the 1-point isometric, which is also sometimes called the oblique view. All right, so that should be pretty straightforward. Now, I want you to do them all on the same page. And what I really want you to do is I want you to do them on the engineering drawing template. I don't want to take the time today to talk too much about why engineers use drawing templates, but if you click on the left side here, it'll download an engineering template to your computer. Okay, but also if you click on here, it'll just open up one just so you can see it really quickly. Okay, so come on, open up, hurry up. It's really taking a sweet time here. Okay, so this is a template that I have posted there for you. And you'll see it has a bunch of features that we'll talk more about next time. But just in general, you see it's got a little place down here where it has the name of your company, or in this case, the name of the school. And it has a place where you can put the title, and you can put all sorts of other information about it, things that we're going to talk about later. Also, you notice on the left side, it has a 1, 2, 3, 4, and down at the bottom here, it has an A, B, C, D. That comes in really handy because if you have a really complex drawing with lots of things on it, and you're sitting there talking to somebody on the phone, and you want to call their attention to a certain thing. So you've got all sorts of stuff in this drawing here, really complicated stuff. And you want to tell somebody to look at the object that's located in section D2. Well, here's the D, here's the 2. So this section right here, see, it makes it really easy. You can say, hey, I got a question about that thing that you show in section D2. I don't really understand that. Can you explain that a little more to me? So you know where section D2 is. So it's a very handy thing, and this is something that almost all engineers do. So I want you guys to get in the habit of doing your engineering drawings on an engineering template. So you can download a copy of the template from this page right here. But also, if you go back into the modules page, you'll see that I've also got another link in there, just because later on, I'm expecting there are going to be other things that you guys are going to draw, and I want you to draw those other things using the engineering template. And so you'll see that I've made a special file right here where you can just, it's the exact same engineering template. It's just a little bit easier to find right here. Okay, so when you guys do your drawings for the assignment today, please do all 4 of the drawings on the same piece of paper. Please do them on the engineering template. Now, some of you are going to say, but Mr. Hendricks, I don't have a printer. Okay, well, in that case, I guess you can't do it on the engineering template. Okay, but if you do have a printer, please download the engineering template and do all 4 of the drawings on the same paper on the engineering template, and then submit it to me here on Canvas. Okay, there will be a submit button on Canvas where you can do that. Okay, so are there any questions about what today's homework is?
Yeah, do the drawings have to be very detailed, or are we just supposed to show that we know how to do the thing?
Just show me that you know how to do the thing.
Okay.
Don't spend a lot of time making it a super detailed drawing. Okay.
All right.
All right. And then I will leave it up to you guys to decide whether you want to, you want to be looking at this bookcase from the top looking down so that you see the tops of all the shelves. Or would you prefer to be like you're on the floor looking up at it so that you're going to see the bottoms of all the shelves? Or you might choose to where you're standing in front of it so that you see the tops of some of the shelves and you see the bottoms of some of the other shelves. That would be an interesting way to do it. I'd be very happy if you guys did it that way. So I'll leave it up to you. Okay, well, that's the assignment. Now we still have a whole half an hour left in class. So remember, even though I'm gonna end the meeting right now, class is not over. We still have another half hour. So use this half hour to do the drawing. You should be able to finish it in a half hour, and then you won't have any homework. Okay, so I'm gonna go ahead and end the class. However, what I will do before I do that is what I'll do is I'll end the recording. So if you guys don't have any questions, you can say, but just type bye in the chat box and I'll see you later. If you do have a question, stick around. I'll turn off the recording here so that you can ask a question without it being recorded.